the software carpentry Unix Shell lesson today. So from the Blackboard site, or Canvas, sorry, still in Blackboard world. You should have already hopefully reviewed the background for this particular lesson. Hopefully you also reviewed the setup. Most of what this setup was about how to get access to a shell environment or a Unix environment on your machine. Of particular importance for those of you that are working from a Windows laptop. The easiest way to do this again is to just install Git for Windows, which we're going to need for the GitHub lesson starting on Thursday, and just to access the shell through Git for Windows. So that's what I'm going to be doing here today. For those that, is there anybody in here that is on a Mac who has never opened their terminal before? Or do you know how to access your terminal? One quick way is to just press the command button, which is that, like, it used to be Apple, the Apple button. It's not the Apple button anymore. I'm dating myself. It's the, I don't know how to describe it. It's sort of like a 4-leaf clover, maybe. So command space, and then that'll bring up a little search bar, and you can type terminal there, and it should find terminal at the very top. If you're on a Linux laptop and you don't know where to find it, I can help you find it. It should be fairly straightforward to find. So yeah, so okay, so this is recording, yeah. So, okay, so a couple things about the software carpentry-like approach that we're going to be taking these first few weeks and sort of building the basics of our Python capabilities before we pivot to the rest of the class. You should have 2 sticky notes. One is pink and one is blue. Usually these are either pink and green or something like that, right? And so those are like little flags. Any Coloradans in here by chance? Anybody from, do you remember Casa Bonita? Or like South Park fans? Yeah. So there's a restaurant called Casa Bonita where it had just horrible Mexican food. They had divers inside the building. And like if you watch the South Park version of this, it's actually pretty accurate. But right at the end of your meal, you got sopapillas, and the sopapillas were like all you can eat, and all you had to do was raise a little flag at your table, right? So when you put the flag up, that meant you needed more sopapillas. They'd put the flag down, you'd eat your sopapillas and iterate, right? And n+1. So similar here, those little Post-it notes are your flags. I will not be bringing you sopapillas though, I'm sorry. The blue one, okay, so we're going to go through the software carpentry lesson, right? And what that looks like is me doing some narrated things on the computer, and also then some parts that are more individually or sort of pair-based, right? So there's a part of the lesson that you go through kind of independently, and what you use those flags for, right, are the blue one, which would normally be green, means I've finished this part of the lesson, right? I've gotten to where you told me to stop, right? And I'm ready, I'm awaiting kind of what we do next, okay? So you will use the blue sticky note and put it like up on your monitor for folks to see, for me to see, right? That's how I can kind of see when folks are ready to move on. And then the pink one is more like kind of a red flag, right? Which says that I'm stuck. There's some kind of issue that I'm encountering. And so that's kind of a, what's nice about this approach is that when you put the pink flag up, right, you can kind of keep, you know, you don't have to like try and like raise your hand and work with the other hand. You can keep working and keep trying to work the problem. The other thing that's nice is, and what I would encourage is for, if you get to the end and your blue flag is up and you're done and just kind of waiting, and somebody around you puts their pink flag up, then this is one of those things where we learn better when we have to sort of teach things. And it's often good when we're kind of helping to peer mentor, right? And so if you see somebody next to you that has their pink flag up and you're done, right, you can turn and say, oh, well, where are you stuck? And maybe there's something that I can help with. The other benefit of this, right, is that even if you're unable to help your neighbor, sometimes it brings up some good issues, right? Like some good discussion for you, the helper, to see. Okay, so so that's how we use this kind of messaging tape, you know, flag system, and we'll do that throughout this sort of first 5 weeks of the skill building unit. Yeah, so what questions do you have to this point about any of that? Okay, so what I would like you to do, and you might want to, so what I would strongly recommend, I'll zoom in on this a little bit. Well, you all have it on your screens, hopefully. I would strongly encourage you to go ahead and also open the software carpentry lesson on your laptop. You can just keep it in a window that's behind, just so that you have it, because I'm going to ask you to go ahead and read through to a certain point in the lesson. So if you can get to the Unix Shell lesson, right, there's a couple things for setup that you have to do. So you have to download this zip file and you have to put it someplace. I'm going to put it in my documents. I'll just save it there, and then I'll have to unzip it. So on my Windows device, I will go to Documents. I will right click here, go to 7-zip, and I will just say extract to shell lesson data, right? So what this is going to do is this should unzip this file and put it in a folder called shell-lesson-data. Okay, and then this should have a whole bunch of other files and folders in it, okay, which we'll be using over the course of this lesson. Okay, so, okay. All right, so let's go. You should have a shell open, okay? And now let's go back, and we're going to go to this first part of the lesson, which is introducing the shell. So this is just some reading here, some real quick kind of review of what the shell is, kind of some different terminology that we will use when we're talking about the shell, a little bit about why this is important, right? Like we have these nice graphical user interfaces that Microsoft, Apple, whoever has invested in, like why are we using this kind of seemingly old school command line, and a little bit about kind of where this lesson goes. So if you could get through the, go ahead and take, it should take no more than about 5-ish, 7-ish minutes to read. And what we'll do is we'll get, once you're done reading Nell's pipeline here, we'll discuss this a little before kind of moving on. Okay, so go ahead and read, use this, use your Post-it notes when you're done, right? So put up the blue flag when you're ready to move on. Yeah. That's a great question. Bash would be best. Do you know how to change? Okay. Okay. I might come back to that once we're done. What's that? Mac by default is Z Shell, which they changed a couple years ago from Bash. There's a way to permanently change it so that it always reverts to Bash. So. Is PowerShell for Windows? It should be, yeah, we could check. Okay. If you try just typing bash, it might reduce, like it might just invoke the bash shell if it exists. Usually there's like 2 or 3 different versions of shell. No, okay. Okay, it might be a version of the bash shell that doesn't quite do everything, but if you ever encounter something that doesn't work, then let me know. Is everybody mostly rounding third base with the reading? Okay. Okay. So as far as I know, nobody's a marine biologist in here. However, for how many of you did you see some similarities in Nell Nemo's use case in your own research? And I'm wondering if anybody might be able to share kind of an analogy of like, here's something that I need to do in my work that looks something like, here's one file and one program that needs to process that one file, and I need to repeat that process seemingly hundreds or thousands of times.
Yeah. So I have to go through around 600 individual pictures of glaciers and track permanent position, but I can't do it all by hand. It's over 20 years. So each glacier is going to have like 60 individual.
Yeah, so I'll repeat that for the recording, right? So this idea that there's a sequence of remote sensing images that are effectively pictures of a glacier, and there needs to be some, and over a 20-year-ish period for a number of different glaciers, there's a whole time series of images and some processing to extract like the location of the end of that glacier, the terminus, needs to be done again and again and again, right? Anyone else? Anything slightly? Yeah, Nate?
Using a data logger recently that takes readings every 10 minutes, but it stores the date and time stamp using New Zealand time, and also saves it as a text file, not a date file. And it was running for like a year. So I tried to just like do a couple of quick things in Excel, and it took me hours.
Yeah, so a really good example, and one we'll get into in a week or so, right, is us as earth and environmental scientists, period, right, that there's usually 2 things that are really, really important in our work. One is when something happened, and 2 is where something happened, and dealing with both of those simultaneously is exceptionally important, right, and often requires a degree of precision, right? We want to be in the right hemisphere, right, and time zone. And sometimes when our data loggers don't exactly work like that, or they use conventions that are different, then we need to go in and be able to, to process all of that data, right? Just do a simple operation on it, and it may be multiple files, right? Maybe all of our data loggers were doing that. And we need some way to process, do something on it as simple as just, hey, you got the date and time wrong. Here's the way to update it. Now I need to do that with, dozens or hundreds of files, right? So yeah, I think all of us can sort of resonate. Something about this resonates with all of us, right? This idea that we could sort of point and click on a program, and that's fine for like one file, right? But doing that for hundreds or thousands just becomes unwieldy. And so the shell provides us a way to automate a lot of those sort of simple tasks, right? To do things again and again and again, all the way from just renaming files, all the way up through running some complex, sequence of code on a whole bunch of individual files, right? So that's all what this lesson is about, right? This lesson is about kind of getting one step lower than that graphical user interface and being able to kind of work with the computer at what we would call a lower level, right? And doing so, although it adds some complication in terms of how we react, one, it helps us automate a bunch of workflows, and two, I would argue, it helps us kind of understand the way the computer is structured a little bit differently, and really that, like, at the end of the day, computers, although they're marvelous machines, right, we have to be very explicit with what we're telling them to do, right? It's often said that a computer is completely unlike the human brain, in that the computer is good at doing a set of well-defined tasks very quickly and repeatedly, right? That's actually very different than the way our brain works, okay? Okay, so go ahead and go back up. What we'll do is we'll go now to the navigating files and directories part of the lesson. So kind of the objectives of this part of the lesson are that you should be able to move around the computer. You'll see what files and directories are there, and you'll be able to specify the location of a file on a computer at the end of this kind of part of the sub lesson. So go ahead and open this part of the lesson. Okay, and go ahead and keep what I'm going to do usually is I will kind of arrange this so that the lesson is open here and my terminal is open here. So hopefully all of you are seeing this. And you can do that as well on your laptop, right? I will do this here so that I can see the lesson. And go ahead and read down to this first pin here, this home directory variation, and then we'll go ahead and get started. And then, yeah, you don't have to read the home directory variation. Stop before you get there. Okay. So the first thing that I want to do, I have my shell open here, right? This is the Git version of it on a Windows machine. And the first thing that I want to do in my shell is figure out where in my computer I am, right? Where this cursor, my mental model for this is this flashing cursor here with the $, which is my prompt. Your prompt might be different, right? I want to know where is this flashing cursor on my computer, right? It is looking at, or it is pointed to a particular directory or folder. We're going to use those terms interchangeably on my computer, and I want to know where. And the way that I do this is using the command pwd for print working directory. Most Unix commands are kind of are an abbreviation of a longer list. So if you're wondering, like, what the heck does pwd, right? Why is pwd tell me my location on the computer? It's because it stands for print working directory, which will print the location to the prompt here, right? And so this is telling me, okay, this is where you're at, right? You are at a location that is /c/users/Lejo Flores. That's my Boise State username, right? If you're using your personal, whatever your personal name is on your own laptop, right, is going to be kind of hopefully where you were pointed to. What I will say briefly about this is that this is actually like a little bit of, so again, this is the Git version, Git for Windows version of the shell. And this is a little bit of a trick, right? So this is this shell kind of giving me the Unix or Linux version of where my home directory is, right? So typically on Windows machines, it's a /, right? So the slash would be going the other direction. And it uses this like C:, is kind of what's often known as your home drive, right? Or your C drive. It's kind of where most of your files live. All this shell is doing is it's taking that same, so it's the same structure that you would get navigating with the graphical user interface, but the shell is just rendering it in a way that a Unix or Linux user would recognize. Okay, so that's an important thing, especially for Windows users to recognize, is that we're still in the same file structure, same directory structure as we would see in Windows Explorer or whatever it's called these days. It's just referred to slightly different, right? The accents are a little bit different, okay? So this is my home directory. Do all of you have something that looks sort of similar to this? Okay. So an important kind of thing to note here, which this part of the lesson is going to tell us about, is a helpful way of thinking about how our file system is structured on our computers, is to think of it like a tree, right? Think of it as a tree with many, many branches. And each one of those branches is kind of separated by one of these slashes, right? And the very first slash that we have, the one that's way here to the left of the print user directory, that is often what we will refer to as the so-called root directory, right? So like a tree, that very first slash is root, okay? We think of that on Linux and Unix machines, probably on Windows as well, as, in root is where all of the really important things live. It's where things live that you don't want to disturb, lest you potentially like delete really important things. So we're often always working somewhere what you might call kind of downstream of root. And so when I typed pwd into my shell, it said you are at C, right? That's that main drive, root C /users/Lejoflores, right? And so the way to think about this is that Lejoflores is a folder inside users, which is itself inside C, okay? So your directory structure, you may be several folders down from that. You may be a folder or two up from that, but it should look something similar to that, right? And so as we move forward and think about these file structures, right, you can think of anytime you see a directory listed like this, the slashes will always tell you something about where in the hierarchy of the file system you are located, right? Whether that's your data or whatever, okay? Okay, so we've now figured out where I am. Okay, so this is the folder that my shell is currently looking in. I want to figure out what the heck is in that folder, right? So the next step for me to do is to list the contents of my directory Lejoflores. And the Linux or Unix command for that is ls for list, okay? And here, I should go back up, right? So this is my main profile directory. And as you can see, it gave me a list of a whole bunch of things, right? A whole bunch of things that I probably don't care about. Okay, so there's this one first thing to note, okay, is that something is different about, for instance, each one of these objects, right, that is listed here on a new line is something that is in that folder somehow, in that Lejoflores folder. So if I highlight this documents thing right here, I will note that documents is different than, well, there's some other things formatted like it, right? But the way that it is displaying, the way that the text is formatted is different, right? One is that it's blue. At least I can see it as blue. If folks happen to be colorblind, apologies. But it is rendered in blue, okay? It is also, it has a slash in front of it, okay? Now, what might that mean or be hinting to us? Yes, it is a directory, right? So these things here are directories, right? So these are folders that are inside that folder Lejoflores, right? And if I could verify that, if I bring open, if I go to, let's see. C users Lejoflores. Right, it's the iconography is kind of different here, but if I look at this, right, there's this thing here called 3D objects. This shows up as a directory here. There's desktop. Desktop shows up as a directory here. There is documents, which shows up here, right? So so this is one clue for both Windows and Mac. Well, any kind of GUI environment is a lot of the things that are rendering here with sort of special icons are often just folders, right? They're just folders that somewhere in the preferences, it's set to have a special icon associated with it, right? The download arrow, the downloads folder with an arrow, the documents folder with a document, but really these are just folders, right? There's nothing different about them other than the preference of the way that it's displayed, okay? Okay, so there's also some things in here. If you take a look at this, right? There's this thing called local settings. It's rendered in cyan. right? And it has an @ after it. And so what might that indicate? Any ideas about how this might be different? Who said that? Yeah, so it's a link, right? So what this is in Unix, in Linux, in Mac operating system, this would show up as just a regular folder that might be colored slightly differently, but this is what we refer to it as a link, right? Or a soft link, right? So what this is doing is it's giving us kind of a shortcut, right, to some other folder somewhere in our computer, and it's showing it to us as if it were a folder of its own, right? So even though it looks like a folder to my ls command, it actually links to somewhere else on my computer. Okay. All right. There's ways to figure out where it links to. I'm not going to go into that quite yet, just in the interests of kind of keeping to move through the lesson. Okay. So one thing that is also interesting is if I look here, I have a file here that starts with .regtrans-ms. And if I look over here in my window environment, I don't see that, right? And so what does this file that starts with a period, what's special about this? Is this file actually, like, why can't I see it here, but I can see it here? It's hidden, right? So this is in particular a hidden file. So it's actually in here. It's just a file that starts with a period. And this is common now across Windows. This is new to Windows, but something that is very common in Linux environments is that hidden files will start with a period. Okay, now why would you want to hide a file? Yeah, so that if I have a bunch of these hidden files here in my window environment, I don't see it. Okay, and if I don't see it here in my window environment, right, or if it's explicitly hidden, if I need to do something actively to go looking for it, why might that be a good thing? Yeah, so people don't, right, get into these files and start mucking with them, okay? It's interesting here because unlike Unix, right? So if this was a Unix device, you would not see these folders, this .config props, .cisco, right? So Windows is not hiding folders, directories that begin with a period, but it is hiding files, okay? But this is always a good clue. Anytime you see a file that starts with a period, and this is a foreshadowing of what we're going to find in the Git lesson, is that if it starts with a period, good idea to not mess with the file unless you actually know what the file is and what you're going to do with it, right? So if the people that create the operating system were trying to hide the file, it's something that you only want to be sort of using and manipulating if you kind of know what you're trying to do with it, okay? And often there will be very structured ways, as will be the case with Git, for actually interacting with that file. Okay, so other than that, right, there's some other files. There's, this like NT user file, right? There's some other things that are here. Again, we're not going to really pay attention to those because they're there. We can note that they're there. That's interesting, but we're not going to touch them. Okay. All right. So what I want to do, well, let's actually try this. I've never tried this on a Windows machine. Let's type ls -f. And okay, cool. So that did not work on my Windows version of Bash, but those of you that are on a Mac, right, what this should have done is only return these links to the folders, right? It should have only listed my folders. I'll try this with a lowercase f, ls space dash minus lowercase f. That didn't do anything. I'll also try with a D. That didn't do anything. I'll try with a capital D. That didn't do anything. Okay, so this is good, right? This is sort of giving me an idea of how Windows is different, right? The other thing that you just saw me do that it's important to sort of come back to is that little thing, right? This dash F in my list command here. So that dash F is what's referred to as a flag, right? So it's a flag that I passed to my list command, and it provided further clarification on what I wanted the computer to do, right? What I was hoping would happen is that when I typed ls space dash f, like it does here in my software carpentry lesson, right over here, what I was hoping it would do was just list off the folders for me, okay? So what I did, which is what commonly an experienced Linux user would do, was if that flag doesn't work, let me try a slight variation on it, right? Let me say minus f, small f, minus D for directory, minus big D for big directory, and none of them worked. Yeah, Tanzila?
Can I do lowercase f and it works?
You did lowercase f and it worked? And you're using get, bash for get? Yeah, okay. That's good to know. So, right, this is the other thing to kind of, that's right. So some folks are reporting that they're using the version of bash for get in Windows for get, and it is working, right? So, so that's a good thing to know, because sometimes things will work in one platform and not the other. For those of you that are working on Macs and ultimately go, for instance, and use like a cluster or a supercomputer, you'll find some slight variations in how these commands and these flags work, okay? But one thing that will help, that's a hint, right, is that anytime we want to kind of get some further advice on how to use a command, right? So me, the person that's been using Unix Linux for a while, what I did was I said, okay, well, let me try some variation, right? Let me just throw some flags at list. And I know that this is not, right, list isn't going to do anything bad like remove or delete any files. It's not going to create any files. So I'm just going to keep throwing flags at it that I think might work. And then what I do is get frustrated and say, none of this is working. What I'll do is I'll try to call up the help message, and I'm going to type minus help. And what it will do is bring up this very long help message, right? So the help message here, when I type ls space dash help, it said, okay, here's how you use this command, right? You type ls, and then you give it any of these options, or these are those flags that I was talking about. And then also, you can specify that you want to list the contents of a specific location, right? We'll talk about how we can do that in a little bit, but if we scroll through, we can see that there's all of these different kinds of lessons, or all of these different kinds of flags and options. Okay, we can, so it does look like It has a -F and capital F option and a -D and capital D option, but they may not have been what I wanted. But there's a whole bunch of other options, right? So I could have done this one, -G, group directories first. Some other helpful ones here are, let's see, we will use -R, recursive. We will use, sometimes -1 is helpful. We'll talk about that later on, right? So, so these are all of the different valid options, all of the different valid flags that we can pass to our list command, okay? So one important thing about Linux and Unix is that all of these commands will be structured similarly, right? There's some command, we've used two already, pwd and ls, and all of them will allow for some option that will usually, some flag that will usually be passed as a dash something, right? Dash F, dash R, dash I, whatever, okay? So you can start building an understanding of how bash works by thinking of that command structure, right? Command followed by option, followed by some other input, which might be a file name, okay? Okay. I will try one more version of this. We'll try to list this, let's see, -G, and see if that gets closer to what I wanted, ls -G, and these are all messed up. Now this is giving me like the full report on this. So anyway, this is confusing. I will have to come back and see exactly what it is trying to do with list. Okay. So now what do we want to do? Now what we want to do is we want to actually get to, where we are in, we want to get to where that data is, right? We want to get to where the data is that Nel Nemo is supposed to be manipulating, right? And so if you recall, right, way back at the beginning of class, I believe that I unzipped that file to a location that is users Lejo Flores in documents, right? So if I type ls again here, presumably, right, this folder of shell lesson data is in that folder documents, right? So relative to me, right, this is the folder that I want is one folder away, and the data that I want is 2 folders away. And so I just need to navigate there, right? So how to navigate directories is that we just use the cd command or call directory. So we would say cd, and I now have to, right? This is a command that requires me to provide some input, right? If I just tell you call directory, okay, your response might be, well, what directory? Where exactly do you want to go, right? Like if I just invoke cd, right, that would be like getting in a taxi, right, or grabbing an Uber and saying, take me, right? And the driver would be like, where, right? So I need to get into documents, and all I do is I type documents, and I don't need to add the / I could, it won't have any difference. But if documents is in fact a folder, a valid folder, when I call cd and provide it with the input documents, it should take me into documents, right? And so an interesting thing just happened there, right? Which I don't know if you saw it, but now, right, before it just said I was in this kind of tilde. tilde is shorthand for your home directory. And that now it says you are in home documents, right? So this is a shorthand for your home directory. And now you're in documents, okay? Okay, so now I'm in documents. I want to get into this Shell lesson data folder. Let's just make sure it's there. How would I list the contents of my directory to make sure that that folder is there? Just ls. It is in fact there, Shell lesson data. Okay, now how would I get to this directory? cd shell dash, and I'm going to increase my productivity by 200% here. I'm going to press the tab button. And wow, right? So that is called tab completion. Okay. So when I typed tab, I had typed enough of the directory name such that when I hit tab, it did this special thing and it said, I know what you're trying to do, right? It would be like saying, again, like an analogy here might be getting in a taxi and saying, I need to go to the air, and the taxi driver saying port, right? I need to go to the airport. So tab completion here helps you a lot. Had I not typed the full name of the directory, right? Had I typed something else, it will actually give me frequently a list of things that have similar starting. So if I had just typed S and hit tab, it would give me a drop down that would have allowed me to arrow through and select the correct directory. Okay. All right. So now I'm here. Presumably, the data that I need, or the folders that are in that Shell lesson data, are in here as well, right? So there's exercise data, and there's North Pacific Gyre. That is the data. Those are the folders that are, right? So I am in fact in the same folder, right? I'm looking at the same folder here, just presented differently. Okay, now let's say I made a mistake. I don't want to be in this folder. I need to be someplace else. Okay, so I want to navigate back up, right? I want to crawl back up a level. So the way that you do that is you just type cd space ... and that gets me into the next directory. So if you saw what happens, now if I type pwd again, I'm in documents again, right? And if I type cd space again, it brings me all the way back to my original directory, my home directory. Okay, C users Lejo Flores. Okay. Another thing that I could do, right, is if I know where I need to go in this directory, I can specify kind of multiple branches, right? If I know the route that I need to take, if I know the branch if I know the branches I need to take, I can append them to that cd command, right? So now what I want to do is not navigate back to documents / shell lesson data. So the way that I can do that is I could just say cd documents shell. Let's see, I'm just going to type S here and hit tab and see what happens. Oh. Okay, there's two things that can happen, right? If you hit tab twice, it'll say, hey, there's a couple different options here, or maybe if I just did S. Oh, okay. When I hit tab here, what it says is here's your different options, right? There's a zip file named shell lesson data, and there's a directory named shell lesson data. If I had more than that, if I had something that was like Shell company climate change emails, I don't know how I thought of that. It would bring up those options, right? So, but I'm fine with this. So I'm going to hit enter here, and I'm back in that directory. I'm back where my data is. Okay. All right. So what can I do now? It may seem like we've like we've kind of gone slowly, but there's now 3 very critical things that we can do on our file system in batch. We can figure out where we're at. We can figure out what else is there. And we can figure out how to navigate elsewhere. Okay. Okay. So let's see. We've gotten through explore other directories. What I would like you to do is read through read through till you get to this general syntax of a shell command, and then put your blue flags up when you get there. And then read, you got resolved, whatever. Okay, I'll come there in just a minute. So, okay, is that good? Actually, read through to the read through to the end here to key points, if you would. Okay. Okay. So go back to okay, now okay. So I think the reason for this is that one of those is right, so yeah. Yeah, and so this is the thing with those like short because once you you're not yeah, okay. So yeah. And then go to the batch, show me. Oh, that's weird. Yeah. So
Yeah, I think that like it would just be like root documents. Yeah, I don't know if it's like root documents. Or if it's like, yeah. So you want to like look at how to
Yeah.
use the document.
Yeah. Yeah.
Yeah, that's good. That's good to know. Yeah, I know there's like some shared documents drive, which is kind of like, that seems dangerous, but.
Yeah.
So then, yep, so you just type C, and from there you just type shell. And then you can put that. Yep. There you go. Yep.
Okay, so I just wanted to stop and highlight this again because this is super helpful and important in that, right? In Bash and in Linux in general, right? All of our commands are structured this way, right? So there's a prompt. In this case, it is the dollar symbol. Somebody who's on a Mac, what is your prompt at the moment? It's also a dollar sign. You have a percentage. Okay, yeah. So the prompt might differ between very specific instances of Linux, okay? But you're always going to have a prompt, and then you're going to provide a command. That command may have options, and that command may also or may not have arguments. It may work without an argument. It may take additional arguments, okay? So in this particular case, right, I'll do one more example, and I will say, I want to know what is in this North Pacific Gyre folder, and I want to do that without CDing, without actually navigating into that directory, okay? The easy way to do that is to just pass list an argument that is the name of this folder, right? So North, and I'm going to tab complete here. It's going to give me the /, and in this case, the / is important because it says, I want to know what is in this directory, okay? And when I hit enter here, it will show me the name of these different files, right? These are kind of a smattering of the sample files that Nell Nemo is going to use in their research, okay? Okay. Any questions about where we're at to this point? Okay. All right. So we're pretty much out of time. Next time, what I would like you to do is we're going to cover this working with files and directories. We will not cover elements of the lesson 4, 5, 6, and 7. Pipes and filters, loops, shell scripts, and finding things. These are all really great if you do anticipate or already need to use Linux to navigate a bunch of folders. Okay, so the idea here is that all the commands that you just used and all the commands that we will use on Thursday can be embedded within a single file, and that file run to automate a whole sequence of commands, right? We can take all these commands and we can put them in a little script, and we can run that shell script to automate a lot of our workflows. Okay, we're not going to cover this because it's a little bit of an advanced subject. I would strongly encourage you, though, if you are interested in this, there's great stuff in here. I'm happy to help. I wrote tons of bash scripts, still write some every once in a while to do stuff. So I'm happy to kind of help lead you through this. Before next time, if you could, work through this part of the lesson down to moving files and directories. Okay, so what we're going to do next time is we'll cover a lot of this ground. We'll actually sort of start from here, but immediately what we're going to pivot into is this idea of version control, right? So we're going to create files, we're going to create new files, and then we're immediately going to put those files under a version control system using Git. And what that's going to allow us to do is to not lose our work, right? So that's a really key thing as graduate students, is to from an early standpoint, start using both version control and some kind of backup system to make sure we don't lose our work. Okay, and so Git is going to help us with that. But it will be very helpful if you come knowing how to create a file, just a simple text file, using a text editor Those of you that are Windows users, I just checked, and this text editor that they used in the lesson called Nano is available in Windows for Git. For those of you that are using a Mac, you can use one called VI or Emacs. I'm thinking about how much to say about Vim. I won't say anything for now. But if you come to class knowing how to open a text editor, write some text in a file, save that text file with a specific name, we'll be in a great spot to start with version control. Okay. Okay, I will see you all Thursday. As a quick side note, not surprisingly, there's no time that works for everybody during regular class time to kind of do some more skill building. Would folks be interested in like a Thursday evening with pizza kind of thing? I'll send out a Google form to see if that's even an option and which nights of the week might be better. But I'm thinking just like 6 to 8 p.m. kind of things. So, okay, I'll send out a Google form. Okay, see you all Thursday. And I will post this to YouTube and put the link on Canvas. Yep.